Alright, here we are back in transformers, and you'll notice that this transformer circuit, as opposed to our previous video, has a much more complete amount of circuitry. Simplified, yes, but complete. Before we were just looking at the schematic symbol, but now we have a voltage source for our primary and we have load devices on our secondary. And you'll notice too that just looking at this, we have a different transformer. It's clearly got a different signal or symbol. It has our dots in different places. It has a different ratio formula. So where our previous transformer was a step-up transformer, this one is a step-down transformer. We have a 7:3 ratio. And so we're expecting our secondary voltage to actually be less than half of our primary voltage because 3 is less than half of 7. And then if we didn't talk about it before, power in is equal to power out on our transformers. So we know that the formula for power is voltage times current. And when you look at your ratios, we use voltage and current in those ratios. And in fact, that ratio is voltage in the primary over voltage in the secondary, and then current in the secondary over current in the primary. So offsetting those two components that make up power while power is equal allow us to use that cross multiplication or ratio method to get the answers for voltage and currents when we're looking for unknowns. Alrighty, let's look at that first question. The first one is the output signal in phase or out of phase with the input signal? Well, if you remember from the last video when we were looking at the very last section of that, we had a signal that was out of phase. We had the dots, which is what indicates whether our signal is in phase or out of phase. On the last video, we had a dot at the top of one side and then at the bottom of the other side. Well, you'll notice on this one, we have dots at the top of both sides. So those dots at the top of both sides indicate that our signal is in phase. Now what that means is that the signal going out is the same as the one coming in. It has the same phase relationship. So let's go ahead and throw it up there so you can see it. And you will notice here, right, you have a negative portion and then a positive portion for your input signal, and then you have that same negative and then positive portion here for your output signal. So our two signals are in phase. Alright, let's take a look at that next question. What type of transformer is this? Well, we already know it is a step-down transformer because of the 7:3 ratio. Now, we also talked about the fact that it's blank there in our symbol rather than having those lines down the middle that the last one had. That blank, I guess, or nothing in between our two transformer sides indicates an air core transformer, which is essentially nothing, so which is why there's nothing there. These are usually used in radio applications, and the reason for that is that the metal, the iron, from the iron cores would interfere with those radio waves. Okay, next one. What is the primary current? This is an exciting one because we're going to go further out in our ratio formula than we have previously. So I'm going to put that ratio formula back up, and we're going to put in the pieces that we already have, which is the number of turns in the primary, the number of turns in the secondary, and the voltage in the primary. So there we go, there's those up there, and now we know from our previous example that to get secondary voltage, we're going to take 105 multiplied by 3, and then we're going to take that number, which is 315, and divide it by 7 to get 45. So the voltage in the secondary is 45. Now, when I'm looking for current, right, because that's the next thing I'm going to look for is current. I'm going to start with current in the secondary. Now I know current is voltage divided by resistance. I have voltage in the secondary and I have resistance in the secondary. So all I have to do is add up my two resistors. They're in series, so I add them together. R1 and R2 are equal to 9K ohms. And so I take my voltage in my secondary, which is 45, divided by 9K ohms. And that gives me current in my secondary of 5 milliamps. Now, I go back to my ratio formula and I throw in my 5 milliamps for secondary current. So now I have secondary current that is 5 milliamps and secondary voltage, which is 45 volts. If I multiply those two together, I get 225 milli. Now then I would take my 225 milli and divide it by the 105 volts I have in my primary, and that gives me 2.14 milliamps, which is current in the primary. And remember, if you were ever asked for primary power or secondary power, they are exactly the same. So it doesn't matter whether or not they asked you for primary or secondary. You can figure either one of them out just using the secondary voltage multiplied by the secondary current. You don't even have to go all the way out to figuring primary current, because they're going to be the same. So as soon as you have the voltage in the secondary and the current in the secondary, you can just multiply them together, and that is power in the primary and power in the secondary, because remember, they are the same. That's what makes that ratio formula work. All right, and that is it for transformers. I'm actually going to work on some filters, RC and RL filters. I had completely forgotten to do those videos. So I do have all the slides set up for that, and we're going to do those next.